How do machine learning engineers avoid overfitting models? Imagine training a model so perfectly on your data that it struggles to handle anything new. That's what overfitting is. It's like memorizing answers instead of understanding the questions. If you want your AI to work well in real life, you need to stop that from happening. One of the simplest ways to do this is by using more data. When a model trains on a larger and more varied set of examples, it learns general patterns instead of memorizing specific details. Think of it like studying with a bigger textbook that covers more topics. The more diverse the data, the less likely the model is to get stuck on irrelevant noise. Another important method is cross-validation. This technique splits your data into smaller parts or folds. The model trains on some parts and tests on others repeatedly. It's like practicing with different quizzes to see if you really understand. This helps tune the model's settings, called hyperparameters, so it performs well on new data, not just the data it trained on. Reducing the complexity of the model also helps. If a model has too many parameters, it can fit every tiny detail, including noise. Regularization techniques add a penalty for complexity, encouraging the model to keep things simple. For example, ridge regression and lasso regression are common methods that limit how big the model's coefficients can get. This way, the model focuses on the most important features. Feature selection or dimensionality reduction is another key step. It involves removing irrelevant or redundant input features. Techniques like principal component analysis transform the data into fewer, more meaningful components. This reduces the chance of the model memorizing unimportant details. Early stopping is a simple but effective trick. During training, the model's performance on validation data is monitored. When the performance stops improving, training is halted. This prevents the model from continuing to fit noise in the data. For neural networks, dropout is a popular method. It randomly disables some neurons during training, forcing the network to relying on multiple pathways. This makes the model more robust and less likely to memorize specific patterns. Data augmentation is especially useful when data is limited. It involves creating new training examples by applying transformations like rotations or flips in images. This increases the diversity of the data, helping the model learn more general features. Avoiding target leakage is also critical. This happens when the model uses information during training that it wouldn't have in real-world predictions. It can lead to overly optimistic results that don't hold up in practice. In real-world applications like ChatGPT, DALL-E, or Midjourney, avoiding overfitting ensures these models generate relevant responses or images for new inputs. For productivity plugins that use AI, well-generalized models produce more reliable and fair outputs, reducing errors and biases. Overall, preventing overfitting is about finding the right balance. It's teaching the model enough so it learns useful patterns without memorizing every detail. This balance makes AI systems more effective, trustworthy, and ready to handle real-world challenges.